All right, so DI 71-1, let's look at number 1. So when we go to graph this, the important things that I want you to pull from it, I know there's a lot of information that I pulled from the video, but the most important pieces of information you need are the vertical asymptotes, any holes or points of discontinuity, and horizontal asymptotes. We're just focusing on horizontal asymptotes in this lesson. In 71-2, we'll be examining oblique asymptotes. And so in that instance, it would be horizontal asymptotes or oblique asymptotes. But right now, we're just focusing on horizontal asymptotes. So the first, vertical asymptotes, you set the denominator equal to 0. And then you solve for it. So 3x minus 6 equals 0. Add 6, divide by 3, get x equals 2. If I plug that 2 back in, I do not get 0 over 0, and so I don't have any holes. Now my horizontal asymptote, the degrees are the same. So x over 3x minus 6, that's a 1, and then that's a 1. So 1 and 1 means they're the same, so we divide the leading terms. So that gives us 1/3. So my horizontal asymptote is x equals 1/3. So now I take that information and I put it on a graph. We said we have x equals 2 for our vertical asymptote. Notice it's going vertically. And then x equals 1/3 for our horizontal asymptote. And it's going horizontally. So now I need to know what my graph looks like. So to do that, I want to pick values. So we create an XY table. And I want to pick values, notice my cursor, on this side of the horizontal asymptote. So on that side of the horizontal asymptote. So like 1 and 0 and -1. And then I could pick values on this side. 3, 4, and 5. Because those are going to give me values to see what the graph looks like on this side. That's going to give me values to make the graph look on that side. And so those are the values that we're going to want to pick. And you take them and you plug them into your function. So for example, if I want to plug in 1, you get 1 over 3 times 1 minus 6. And so I'm going to get 1 over 3 minus 6. I get 1 over -3, so that's -1/3. And you're going to plug every single one. If I plug in 0, you get 0 over 3 times 0 minus 6, 0 over -6, and so that's the same as 0. Now it also could be helpful if we use a graphing utility to help us with that. And so you can actually just enter your function into the graphing utility. So x divided by 3x minus 6. And so every single graph will have a table feature. So if you go over to the table feature, it shows all those values that we'd plug in. So 1, see we got -1/3, 0 is 0, -1 is 0.11. If I plugged in 3, it's 1. If I plugged in 4, it's 2/3 or 0.66, and then 5 is 0.55. Now I can take those values and I can take them and I can plot them on my graph. So at 1, we said it's -1/3. So at 1, it's -1/3. And then at 0, it's 0. And then at -1, it's 0.11. So it's like really close. And so my graph hugs the asymptote. Hugs the asymptote. At 3, we said it's 1. 4, it's 2/3. And then that's 0.55. It's going to hug the asymptote. Hug the asymptote. And so your graphs hug the asymptotes along there. Next one, let's look at number 3. So f of x equals x plus 7 over x plus 3 squared. So same idea, we want to find our horizontal asymptotes, vertical asymptotes, and any holes if any exist. So horizontal asymptotes, you look at the degrees. Well, on the top it's x. On the bottom, if I multiply this through, right, that's x plus 3 times x plus 3. Those are the same thing. So x times x would give me an x squared. Well, the degree is larger in the denominator, and so my horizontal asymptote is automatically y equals 0. Then my vertical asymptotes, if I set the bottom equal to 0, x plus 3 equals 0, you get x equals negative 3. If I take that negative 3 and I plug it back in, I do not get 0 over 0, so there are no holes. So now we go and graph it. At negative 3, that's my vertical asymptote. And then at y equals 0 is my horizontal asymptote. So now I can take points and I can plot it. We have to take or make a table. And so I want to plug in values on this side. So what are the values on that side of my vertical asymptote? So if that's negative 3, then I have negative 4, negative 5, negative 6. And then plug in values on this side of it. So if that's negative 3, negative 2, negative 1, 0. So now I need to take all this information and I need to plug it in. So I could just plug in like negative 4 and say negative 4 plus 7 over negative 4 plus 3 squared. Right, I just replace the x with it, so that's going to give me 3 over negative 1 squared, so that's just 3. So we can do that. We can go through each one and do boom, 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 and be able to plug those in. Or what we can do is we can use our graphing utility again. Now this time, if I want to use Desmos, if I want to plug this in, x plus 7 over x plus 3 squared. If I hit this edit list and then I hit convert to table, it'll give me all the values. So I did negative 4. Let's verify that. See, 3. If I want to plug in negative 5, so that's going to be 0.5. If I want to do negative 6, 0.11. And so I can go through and I can graph that. At negative 4, it was 3. At negative 5, it was 0.5. And then at negative 6, it was 11. And so we can go through and we can graph that. And then negative 2. That gives us 5. At negative 1, that gives us 1.5, and at 0, it's 0.7, so 1.5, and we said 0 is 0.77. And so I can graph that. So at negative 2, it's 5. At negative 1, it's 1.5. And then at 0, it's 0.77. And so they can go through and we can model that. And so looks similar to what we have here, right? The main point though is the fact that we don't just want to look at this and graph it, we want to get these points. Okay, that's the most important feature, is grabbing those points to be able to model it. Saves us time instead of plugging in, plugging in, plugging in. We want to quickly be able to find them. Alright, so now moving on. Let's do number 7. y equals secant of 3x minus 2 pi plus 4. Alright, so when we're graphing this, we want to pretend like it's cosine. Cosine means it's going to have this type of shape. And we have to take this and put it between 0 and 2 pi. So we're going to add 2 pi to every side. Divide everything by 3. And so 2 pi thirds is less than or equal to x, which is less than or equal to 4 pi thirds. So now what we need to do is we have to take that and create that value box. So 2 pi thirds is here, 4 pi thirds is here. Add the ends, divide by 2. That's going to give us 3 pi thirds. Add the ends, divide by 2 is going to give us 5 pi 6. So that's 4 pi 6. That's 6 pi 6. And that's 8 pi 6. So it's going up by 1 pi 6 every time. You can look at it 4 pi 6, 5 pi 6, 6 pi 6, so 7 pi 6. So now I can label everything on my graph. So the vertical shift is +4. And it's going to start here at 4 pi 6. And so it starts up at the amplitude, crosses at 5 pi 6, goes below at 6 pi 6, crosses again at 7 pi 6, and then goes back on top at 8 pi 6. And so here, where it crosses the, because it's secant, where it crosses the center line, and then we do parabolas at the peaks. And that is one cycle. And then number 9. 45, 45, 90. So U, V, and 4. So the ratio is T, T, and T root 2. So if I say 4 equals T root 2, divide both sides by root 2. T equals 4 over root 2. And so rationalize it. To root 2. So this is going to be 2 root 2. This is going to be 2 root 2. So U equals V, which equals 2 root 2.